Alright, so this is what everything looks like once it's connected. We still have our negative wire coming in, going to the battery, positive wire going to the battery, which are connected over there. And then we have on the toroid over here, we have primary number 1. It's going all the way around, goes into channel 1 of the hex controller. Then we have primary number 2 over here, follow that one around, all the way it goes into channel 3. Notice that I said in the beginning that we'll only be using channel 1, 3 and 5 for this experiment, hence that one goes to number 3. And then finally over here we have primary number 3, and that one goes all the way around into channel number 5 on the hex controller, which is that MOSFET over there. So that's what it connects up to. This is still then obviously our recovery diode. This is what we'll actually be using to charge the battery once everything's running. So with everything connected, the circuit being on, you can still see that it's still going up on the scope over there. You can see it's pulsing away. I still have the common wires in my hand over here, so the toroid is not powered obviously at the moment. So I'll go ahead and do that, and then we'll quickly have a look at what the circuit looks like in terms of voltages. So I'll just connect that up. There we go. And then we'll grab a voltmeter, multimeter. Excuse my one-handed maneuvers here. It's a bit difficult holding the camera and doing everything with one hand, but I'll try. Going in there, going in there. Okay. Now note that the program that's loaded on the hex controller at the moment is the normal hydroxy program, so it's set up for normal hydroxy production. So at this point in time the circuit is behaving as per a normal circuit, and you can see that it is drawing power as per usual, and it'll continue to go down as a normal circuit does. So 12.834, 12.833, and we can carry on looking at it until we blue in the face, and eventually it will go down and die on us. Okay, so I'm going to keep it here just a little while longer so you can actually see that it is going down. 0.832. Alright, so that's basically the circuit in operation under normal conditions. It's not doing anything funny. It's behaving as per normal. 12.831. It's carrying going down. Alright, so what I'm going to do now is I'm quickly going to connect up my laptop, and I'm going to show you the code I've written for the hex controller that enables us to do the charging portion. Now I'm going to try and do this live so that you can see what I'm doing. First of all, let me just take out the multimeter, and then I'm going to take off the toroid, because the moment that you hit the program button, all the MOSFETs actually goes into completely connected, which is a problem because you actually end up frying your chip and half of your circuit with that as well. So now excuse all the wires because now it's starting to get a bit more intense here, but I'm going to try and do everything as live as I humanly possibly can. So grabbing my laptop, I'm going to take the ISP cable from the laptop and plug that into the circuit, which goes over there. Okay, connect it up. Now let's have a look at the programming. Okay, so I'm using the ISP cable that came with it. Now essentially this is the normal circuit as Bob gave it to us. I can't really go into this circuit because it is not mine, and I respect Bob's non-disclosure agreement that I have with him. So what I can show you is the code that I've written myself, because that after all is my code. So I'll quickly get that up. So now what we have in terms of the normal code is we have the timing set up so that each of the frequencies, or each of the channels, pulses at a different frequency. Now when we do our power generation, we do not need to do that. All we need a very fast rising field and a very fast collapsing field, and we need to have as many of them as humanly possible, and obviously without saturating our core. Now this is a micrometals core as well, so this core can carry quite high frequency, so I'm not too worried about the core as such. I'm also using the silver coated Teflon wire, of course, so I'm not worried about the wires. And the hex controller is built with very high spec components as well, so everything else here works like a charm. So I'll quickly go through the setup of the program inside of Bascom. One of my other friends have asked me to do this, so I'll just quickly show you. What I do is I select the programmer. Let me just zoom inside slightly more. I select the programmer, and then I go down to the normal STK200, STK300 serial programmer. I'll make sure that I set it on to parallel, port 378, and to set it to auto verify. Okay, once done, I can go into my program, and I'll just zoom out slightly. There's a bit of standard housekeeping, just setting up the timers and everything else, configuring the ports, which goes where, and then just saying the port values. Now what I've done in terms of the pulsing, this is the actual main part of the program, and you can see it's very basic. All I'm saying for this thing is to go into a loop and saying for y equals 0 to 6, pulse out port D at the value of y, which is 0 at this present moment, then pulse out port B, which is 0, and then loop it again. So then it goes back to y. So y will change to 1 now, and y will become 1. Pulse the one port, pulse the other port, y will become 2, pulse it again until y is equals to 6, and then just loop it all over again. So it's a very, very basic program, and this just gets as many pulses in as possible. I have been able to get it even quicker than this by pulsing just the right ports that I want, but this works just as well. So for the purpose of explanation, I'll keep on showing you this one. So now I'm going to hit the program button and just give you a final shot of what the scope looks like right now. So you can see the pulses are there, they're nicely timed out. Notice the little drifting that you see there. It's because the phase is being set up so that it works in 120 degrees, and my trigger is not set up to obviously trigger it completely right. So that's the little drifting you see over there. This program that I have running on here is actually, I coded it slightly badly, so that's a little bit of, yeah, things I still need to learn. So I'm going to go back into Bascom over here. I'm going to compile the program, hit F7, that compiles it. Then I'm going to hit F4 so we can get open the programming screen. Now what I want to show you here quickly is I do this every single time I program it, just to make double sure. I go to the lock and fuse bits, then it actually reads everything off my chip. Notice that it automatically detected my chip as an Atmega48 chip. And what I look for here every single time is to have a look at fuse bit KLA or A987. Okay, this is where you actually set the speed of the processor. Notice that we do not use the onboard processor, but we use an external crystal, value being 1110, 1110. The easiest way to remember this is to select just the second one from the bottom every single time. Okay, select it, and then also make double sure that fuse bit C is set so that the clock divided by 8 is disabled. Otherwise your program will run at 1/8 the speed of what it can actually run at. So those are the two most important ones I look for. Once I can see that they are set as per standard, I'm happy to proceed, and I carry on. Going back to the flash ROM, this is now the code. It's obviously been compiled into a bin file, so we are ready to upload it. I'll quickly show you what it looks like on the scope. I'm going to hit the erase button over there, so you can see there it erases the chip. The moment I hit it, it looks like that. It's completely erased. Now it's just polling for input from me, and then I'm going to go back here and I'm going to change it over to write the buffer. This is now the buffer that we have over here, the one I've just compiled. So I'm going to write the buffer to the flash ROM, hit that up, it writes, it verifies. Now you can see on the scope I have tons of tiny little pulses. Now note that the pulses are a little further apart, but notice how small they are. So the duty cycle has come down from somewhere between about, I think it was about 8 or 10%, down to almost 0.3%. Now this is really exactly the thing we need, because this will create extremely sharp pulses with a very fast rising time and a very fast falling time, which will then essentially interact with our near field, and that's exactly what we want for the charging. So I'm going to be disconnecting this charging portion over here, or not the charging portion, the programming portion. Take that out of the ISP port, and then I'll show you what it looks like now.